Thank you all for joining us. This is part of our fall virtual colloquium series. Today we have Mr. Bryan Gaither, a professional math scientist at Austin Peay State University, and he'll be giving us a live demo show focused on fire and pressure. So whenever you're ready to start, Bryan, go ahead. Thank you.
Okay, so I'm going to try and talk into my mic loud. I've got a raging boil going with this torch. I'm going to start working on my PPE. Normally I have a student that helps me do this, but obviously that can't happen right now. So the barrel is, it's got a really good rolling boil to it. And what we're going to do is I'm going to cut the propane, and then I'm going to cap it as fast as I can. So I'm going to go ahead and just do that real fast because it's ready to go. And then I'll talk a little bit more about it. Okay, this is the hard part to do by yourself. This 55-gallon drum is now filled with nothing but water vapor. We want to get it nice and tight, good and sealed. And this is why I wear a leather jacket. Okay. Now I'm going to lift it up. Okay. Right about there. I'm going to pull this burner out. You can actually hear it going, trying to go. And now, if I can get this jacket off, I'm going to start spraying it with really, really cold, chilled water. Maybe, if I can get this jacket off. So I've got an intercooler over here, a heat exchanger that is running garden hose water through chilled ice water with a little salt in it. So we're going to cool this down and see what happens. Uh-oh. I lost water pressure. Okay, I'm just going to throw water at it then. All you gotta do is watch what happens to the barrel. So all that water vapor in there is going to condense back down to a very small amount of water. Whew, that is cold. Let me see if I can get water pressure back. Just keep an eye on that barrel. Well, this is the first hiccup. We'll see how many we have. Oh, you know what? I think I got it too cold. I think I froze it. I don't have a cup or anything. Yeah, I do. All right, note to self, too cold. Now, I've got earbuds in, which are tight-fitting, but when you're this close to the barrel, you have to wear hearing protection because the concussive force is extremely loud. All right, not really a great start so far, but just give it time. Sometimes it's instant, sometimes it's 2 minutes. That's kind of the fun of it. Still good on audio? All right. Maybe?
We are good on audio.
Okay, awesome. I really want to walk past it to start prepping other stuff, but I know absolutely as soon as I do, it's going to go. Every once in a while, maybe 1 out of 10, I have to smack it with a wrench to kind of set it off. Philip, turn that valve. Woo! All right, turn it off. Okay. So, sorry the water system froze up. But as you can see, that thing has quite a bit of damage to it. And it actually broke 2 steel wires that it was suspended from. So there's 15 PSI, basically at sea level. So on every square inch, there's 15 pounds pushing on it. And all that water vapor condenses back down into, a small amount of water. So it pulls a vacuum on it and all the atmosphere crushes it because nature wants to be at equilibrium. And so it wants to be equal. So it wanted to get into that barrel. My next demo here is the same principle. It is a 700-mile-per-hour ping pong cannon. And I have it prepped now. I am going to turn on the vacuum system. And I'm actually going to switch cameras. So I'm using a HDMI system, and the screen will say no signal for a second, and it'll come back. Okay, so that is at the far end of the barrel. And we're gonna give it, okay. I'm gonna go ahead and, so I have, let me go back. Either end, this is a 16-foot piece of PVC. And on either end, I have sheets of Mylar on there, like space blankets. And Mylar is really, really strong. I'm pulling as much, it's not a perfect vacuum, but I'm pulling as much air out of it as I possibly can. So we're gonna take a 4-ounce ping pong ball and utterly destroy that can. When I rupture this end, all that atmosphere, you imagine a giant column of air straight up above you. All of that is pushing down and wants to get into that tube and equalize it. So let me show you what happens to that can. And it'll just vanish, and then I'll bring it back in frame. Ready? All right, let me get this extremely warm barrel out of my way. Oh, wow. So that is what it did to the can. Now, it's going to take me just a second to get it reloaded. And in building this, I learned way too much about ping pong balls because it was either 2006 or 2016. The governing body changed from the professional, governing body changed from 38 millimeter to 40 millimeter ping pong balls, which are the difference of the inner diameter of the barrel causes them to stick. So sometimes it's actually really hard to find the right size ping pong balls. There is a little piece of Mylar in there, and I want to get out. 1 second. I don't want this ball to jam up because this time, just to show you the power of it, we are going to punch through a piece of 1/4 inch plywood. All right, there we go. Okay. So we saw what 700-mile-per-hour 4-ounce ping pong ball can do to a can. Let's see what it can do to this piece of plywood. I also built, I'll show you on the next frame, a Venturi valve that goes on the front, and I use CO2 fire extinguishers as a kicker, and that expanding gas accelerates it up to, we bought a chronographer and measured it at, I think max was like 1,270 miles per hour. Okay, keep an eye on that plywood. Ready, go. So, I love doing this plywood because it truly is a comically round hole. Okay, and so I've just been using my pocket knife to puncture that end, but I have this rigged up with a metal frame because it's so powerful. CO2 sprays in here, and it comes so quickly that it'll actually rupture that film, but it's open here. And so that fast-moving CO2 actually creates low pressure in here and pulls even more air in. So it pumps that ball to a crazy velocity. Okay, let me move the camera because I don't know if you can see this in the background, but I went to the salvage yard and got a car because I've been having a lot of fun learning to use thermite. So on the very top, you can see there is a ceramic terracotta pot. Inside of it is a steel tube that I designed that funnel with a funnel on the bottom so that when we ignite thermite, it's going to all come down, land on the roof, and hopefully burn straight through. And I thought it would actually be cooler to look through here and just watch it burn straight down. Now, I'm going to try and light this remotely. Actually, hold on. So the most important thing about doing crazy science demos is doing them safe. And when the thermite ignites, it will blast up a little bit and then go through. And I want to be prepared for anything to happen. So I'm actually going to gear up before I prime what I hope is going to be a really awesome remote start for it. And if not, I will climb up there and light it with a torch. I just really did not want to do that because I'm wearing a bulky knee brace right now. So a friend of mine was very nice and donated this jacket because I really don't want to get destroyed by raining molten metal. Let me get this microphone adjusted. Okay. So I also want to have everything ready because it's definitely going to start part of that car on fire. So my main goal is to protect myself from raining metal and, you know, face shield, everything. So I actually took my Halloween costume, which is a legit steel helmet, and added a splash guard. These are splash goggles and a face shield. Okay, so I'm gonna switch camera angles. Philip, is audio still good? Okay, I know it's all muffled. Okay, so I am going to prime this because I was too scared to prime it, but I made a remote control to see if we can ignite it without me having to climb up there. But I was too afraid I was gonna fire it off too early. Okay. System primed. Fire extinguishers ready. View looks good. And I've never done this through steel, so I don't know what's gonna happen. So let's try it. Oh, that might work. I have to get the thermite cold enough so it quits igniting. Let me grab the second extinguisher. I'm gonna go on the back side, get a better angle. Yeah, that thermite itself is so hot, and the steel is so hot. All right. And I brought another backup. So I brought ABC rated fire extinguishers. Okay. I will keep an eye on that for a minute. And sorry, but my Bluetooth just turned off. But you guys can still hear me, correct?
We can still hear you.
I don't know why it keeps doing this. It's very annoying. Okay, back at it. All right, so that's gonna smolder for a bit. So, I can't find my microphone. Okay. I'm willing to take questions, but I'm gonna double check the fire.
Sounds good. Are you ready for some questions?
Yeah. Sorry, you can go ahead.
Awesome, sorry. So we have a couple about the different demos that you did. How does the wrench help set off crushing the barrel, and what do you do with the crushed steel drums when you're done with them?
Oh, actually, okay, hold on one second. Huh? Yeah, I'm gonna show them. So these barrels, I buy them brand new because while I like recycling, I don't want to recycle any barrels that aren't brand new because they could have had hydrocarbons in them, and that's a bomb. So we have an artist here, Michael Dickens, I think, who does some artwork with them, and so I have a graveyard of destruction of saved barrels because I just don't have the heart to throw them out, and they're expensive. So, and you have to pay freight shipping just to get one.
Wow. How does a wrench help set off the crushing of the barrel?
So even like as soon as I put that top on, this top started to cave. So it immediately starts to cool down. And it's like always at the brink of wanting to crush. And if you just give it the tiniest little point, it'll set it off.
Awesome. So we have some for the ping pong demo as well. Why aren't the ping pong balls crushed by the vacuum?
So a sphere is a really strong shape. And so I imagine it expands it slightly, but I think it's just a really strong, thick plastic. Most of them get completely decimated. I don't know that I'm going to be able to find one. Oh, here's one. Can you look and make sure there's no fire damage? Any on the other side? I don't see any smoke, but I didn't have eyes over there. So these are really cheap and strong ones. So it just kind of smushed it. But normally they just obliterate.
Awesome. What do you use to remove the air from inside the PVC?
So I've used, as a test, I use our really good Pfeiffer pump, which is like a lab grade pump. But for this, I just use a small demo vacuum. And it goes to this setup right here, which is a T, and then the 90 degree that pulls the air out of there, and then the gauge on the T, so I know when it's at vacuum that we want.
Thank you. How difficult was it to get permission for a fire on campus?
It's getting less and less difficult as well, my administration knows that before I even come to them with a crazy idea, I already have a safety plan in place. You know, I talked to the firefighters last time to make sure, you know, how to put out the fire and everything. But yeah, not everybody can or should do it. But I always make sure it's in an environment that I can control. I've actually cordoned off a huge space back there so that students, you know, because we're in the middle of the day of classes, to make sure nobody was back there. I've got people watching out for it. We put out an announcement today because this area that we're in, it's all brick. So that barrel crush and that ping pong cannon are extremely loud, and it echoes, reverbs off of this, and it sounds even louder out there.
What mix of metals and oxides did you use for the thermite?
So the very first time we did it, we got, so it's iron oxide and aluminum powder. The first time that we did it, we did 1.3 pounds altogether mixed. I think it's like a 1-to-3 ratio of iron oxide and aluminum. And that was lab grade. So 1.3 pounds of lab grade was $600. And then I found this company, Skylighter Pyrotechnics online, that I can get volume from for way, way cheap. So that was 16 pounds, and that was $200 after expedited shipping.
That's impressive. What's under the car?
So it's not so bad this time because it's on a concrete pad, but that thermite is hot enough to ignite asphalt. So Hymanson Steel is where I got this car and the airplane wing that I did last time. And I also got this frame, and that suspends it above a horse trough filled with sand. So that thermite, which you saw was pouring molten through that car, landed in the sand and will solidify at some point.
One more about the barrel. Could you pour LN2 into the barrels and cap them to puff them back up? I know it's a bomb, so you'd have to measure carefully.
I don't know. I mean, that thing is pretty well smashed. I don't think you can get it back.
Yeah. And then one more fun question. They liked your helmet, so what are you going to be for Halloween this year?
Oh, I don't know. So that is from our student organization, our SPS. Student organization is called Del Square Psi, and I'm actually a graduate of Austin Peay, 2009. And even back then, we used to do a lot of outreach. And my favorite event of the year is something called GHOST. It's a acronym for Greater Halloween Opportunity, Safe Trick-or-Treating for the Neighborhood. And people set up tables, and some people build stuff, and then we build absurd things. I wish we were over in my shop right now because I was standing in armor with that helmet on top of like a 14-foot castle we built with a dragon's head that I built with the CO2 fire extinguisher breath, just like entertaining the kids. So yeah, I don't know if we're gonna do. I don't think we're gonna do Ghost this year. I don't know. Haven't thought about it yet. Usually I let the students pick what the build is gonna be, and then I'll come up with something.
That sounds awesome.
Yeah, it's awesome, and it's great for the neighborhood, and students get really involved in it.
Other SPS chapters, take note. You can do this. Do you get glass or glassy materials from dropping molten thermite into the sand?
I don't know that it's actually hot enough to melt the sand. It just kind of solidifies into a chunk, which is now going to be a trophy for me.
From your 16-pound thermite.
Yeah.
I think that's all the questions we have. If there's anybody else has a question, put it in the chat now. Otherwise, I think we are good unless there's anything else you'd like to add.
Just, be safe. I know this is a unique situation, but it's an opportunity. I'm learning all kinds of video editing that I've wanted to do for years. So try and take advantage of the situation.
Thanks. One more question, sorry. Could you possibly recycle the metal from the thermite?
I don't know if it would be pure enough. I'm not sure. I'm not a chemist, so I don't quite know.
Awesome. And then somebody says send pics of the trophy sometime. So if you want to send those to us, we can post them on social media for you.
I've also I cut out a piece of the airplane wing as a trophy as well. So
oh my gosh.
Yeah, I'm happy to send pictures.
That would be awesome. Thank you. I think that's it. Everybody says thank you for a great demo. We really appreciate you taking time out of your day to do this, as well as your student helper back there. This was amazing, and we are recording this, so it will be posted. If you guys have any questions, feel free to email us, and we will have a wonderful rest of your day.
Awesome. See you. Be safe.
Bye, guys.